Everybody. How's everybody doing? Good evening. Sorry, I was having like a little 80s jam moment, so I thought I would share with you all. And I'm learning how to do new things on Zoom every day, so if you haven't figured that out. Okay, let's get rid of that. All right, let's see, we've got some students here in person. Well, not in person, synchronously. That works. So, okay. I don't know why my camera today keeps like wanting to make me blurry and then make me like in focus. Focus. That's the word I couldn't think of. Focus. Okay. Let's do this. Sooner we get started, the sooner we get finished. So let's get to it. So today, oh, few things, a few bits and bobs, okay? So number one, Proctor Track. So I was on the phone or in Zoom meetings with most of IT and some students all day long today. And we're having an issue. We think we have figured it out and we think we've resolved it, but I am not going to implement Proctor Track again this week. I will go ahead and do it starting next week. So if you see it pop up, you've not done your onboarding, I will be shooting you an email to go ahead and do your onboarding. I also want to pass on to each and every one of you the huge, huge thank you from the IT department for bringing the official Carolina University crash test dummies when it comes to Proctor Track. Just so everybody knows, I'm, typically my quizzes are open book, open notes. So there's not really anything that's going to show up on Proctor Track that will ding your grade other than the fact that if you just don't use it. We are looking for feedback and things that you're having go wrong and things like that, because we want to iron those things out now prior to it being implemented across the university, more than likely starting in the fall. So it is something that, you will kind of be encountering unless you're graduating. One thing I just wanted to let you know, the onboarding system is more than likely going to take place during either a freshman orientation, new student orientation. So that whole onboarding process will not have to be done again. And if you have onboarded for this course and you go to another course that is using Proctor Track, you do not have to do onboarding a second time. Okay, so that's going to be streamlined a little bit better throughout the university. So it's not done within the class, it's done outside of the class. It's going to be one of those steps. You get your ID, you do your Proctor Track onboarding, things like that. It's just going to be one of those steps. But again, Terrell wanted me to pass on to every single one of you a huge, huge thank you for being patient and for trying to break the system and breaking it, so that we can make sure that all of these kinks are worked out prior to it going live for the university. Secondly, the grades have been looking really good coming in. The biggest thing I'm seeing so far is just people not turning in assignments. I gave feedback. If it's after the due date, it's really hard for me to give feedback because I'm kind of in the mode of the next set of modules, but I will try my best. As of right now, I believe everything that I had in my inbox is graded and good to go. So please make sure you are aware of that. Third, if you are watching asynchronous, please go back and watch the class information video. It is very important. It's going to explain to you how my classes work. The biggest thing that I want to stress in that is the participation grade for the week. You need to watch it through Edpuzzle, which is embedded into the Carolina University system, and it shows up as a video in your overview for the week. And all you have to do is click login with your Google account, or log in using Google with your school email account, watch the video and answer the questions. Okay, that's how you get the participation grade. There were several students that did not access the videos, so therefore they got zeros for that participation grade. Participation is all or nothing, okay? If you attend in person and your name shows up on my student roster as I'm sitting here, you automatically get the full amount of credit for that course. If you do all of the questions, you automatically get all the credit, okay? It's an all or nothing. There is no partial credit for that. I think that's it. So if you have, again, please go back and watch that class information from week 1. There's a lot of good information in there. Okay, let's get going. It is like really bright out. I think that might be why my camera is being a little wonky with it when it comes to focusing. I know we had like really crazy storms today. I don't know if anyone else did, but we had kind of crazy storms today and it was a little odd. Okay. Let's get started today with module or slash chapter 3, data and business intelligence. So again, these are our major topics that we are going to be looking at today. We're going to be talking about databases and how we manage those. We're going to look at data warehouses. We're going to look at database design trends, what a data mart is. Then we're going to kind of transfer our thinking from what do we do with the data? How do we store it? How do we access it? Stuff like that. And then into the how do we use it? So we're going to talk about business analytics, big data and predictive analytics, BI visualization, and database marketing. So just an FYI, there's probably a lot of big words in here that I probably will say wrong on the first try because my brain is a little fried today on this lovely Monday, but that's okay. Let's start off with a database. So we've kind of touched on what a database is. It's a collection of related data that is stored in a central location, or it could be in multiple locations. There is a data hierarchy, which is a structure and an organization to that data. That data is going to involve records, fields, and files, okay? And again, there is a structure to what those things are. The other thing that we have for a DBMS is a database management system, like you can see right here, DBMS. This is going to be your software for creating, sorting, maintaining, and accessing those database files and the records. It is what is going to make using these databases the most efficient as possible. So when we're looking at a DBMS, we're talking about things like Microsoft Access. So I believe most people have access to Microsoft Access. Yeah, I always say that and it just sounds odd. But I think most people have access to Microsoft Access. It is different than if you brought up just a plain old Excel spreadsheet. Okay, and that's because you're looking at a database management system as opposed to just a spreadsheet. They are different. Okay, so we're going to look at types of data, we're going to look at files, and we're going to look a little bit into the design. So first, let's look into types of data. When data can be stored two different ways, or I'm sorry, data can be gathered two different ways. We can gather data from an internal location, which is collected from within your organization. It's stored in an organizational internal database. And typically it's going to be used by functional information systems. Okay. Going back to what we talked about last week, these are these functional systems that are working within your organization. External types of data, on the other hand, is going to be the opposite, right? It can come from a very wide variety of sources, stored in a data warehouse. It's coming from outside of your organization. So quick question, what are some examples of external data? And what are some examples of internal data? Okay, let's go back. Let's go ahead and look into the different files and the way that we access these files when we're talking about a database. We've got sequential access, we've got random access, and we have indexed access, indexed sequential access. So let's go ahead, let's look at sequential access. Now, sequential access is going to have your records or files that are organized and processed in a specific numerical or sequential order. So either they're going to be numbered 1 to 10, and they're going to be stored that way, or it could be something like a sequential order like A to Z, okay? So that's what I mean by a sequential order. It's some kind of order that makes sense. Another sequential type of order could be by date. So a January date, disregarding of the year, a January date might be coming before a June date. So in a sequential access, the records are stored based on what we call a primary key. Now, a primary key is a unique number to that record, which means no other record in the database can have the same value as another record when you're looking at the primary key. For example, the best example is social security numbers for people. Okay, every single person has a different social security number. You will never have a duplicate of a social security number. A lot of times things like banks will have those account numbers. Your account number is unique to you. Okay, that could also be a primary key. It's a lot of times sequential access is used for backup. It is used to archive files because you're looking at things that rarely need to be updated. Okay, if you're updating something in a sequence, you have to move that sequence around and it can kind of get a little difficult and a little wonky. Random access. These are going to be records that can be accessed in any order, regardless of their physical locations in media storage. So they may not be all in one location. They may not all be on one server. Okay. It could be anywhere. It is very fast and very effective when it is a small number of records needing to be processed at one time. So say you are running a daily report or a weekly report, that can be considered a very small number of records as opposed to a quarterly or an annual or biannual or, those type of reports. These records are going to be stored on magnetic disks to get that speed that we need when we're talking about random access. Now, what's making random access fast is that it does not have to look for large chunks of available memory on these disks, so it can kind of put its records wherever it finds room. Last but not least, we have indexed sequential. So it's ISAM. The records are accessed either sequentially or randomly. Okay, it's depending upon how many you're accessing. If you're accessing a very small number of records, it's going to use the random access. If you are doing a much larger number of records, it's going to use the sequential. So what it's doing is it's pulling the best of both worlds here, okay? So it is, again, dependent on how many types or how much of the data you're actually trying to pull. The index structure is going to have two separate parts to it. Ugh. So instead of having the primary key, it has a two-part index where the first part of that is some type of value, okay, and the second part of that is a pointer. Now, if you don't know what a pointer is an address of a location on a disk that is going to contain something, okay? So you're going to have an indexed value and you're going to have the address of where that information is stored. That chunk of memory that is needed is much smaller than the actual chunk of memory that contains the data. So it's going to look through this index structure to find what it needs, and then it's going to access it in the way that it makes it the fastest. So the biggest difference, again, is this two-part indexed structure. So those are three different methods for accessing files. Last, let's go ahead and look at design. So you can look at your database in two different ways. We look at it as through a physical view or a logical view. So a physical view is going to explain to you how the data is stored and retrieved from whatever storage media it is on. Now, the logical view, on the other hand, is going to be how it appears to users, how it can be organized, how it's retrieved. We're going to see an example of how this looks different here in just a minute. Depending upon who your user is, you can have multiple views based on your user, okay? So say you've got a user that is in the finance department, they may have one logical view, and that might be different than someone working in a sales department, okay? And that is okay. Your data model is going to determine how your data is created, represented, organized, and maintained. Okay, and what's going to be in this data model? Inside your data model, you're going to have a structure, you're going to have operations that you want to do on it, and you want to have integrity rules. And integrity rules are going to help make sure that you have data that is valid. Because remember, we talked about it last time, garbage in, garbage out. Okay, so we want to make sure what's going in our database is correct. A very simple integrity rule could be enter in a zip code, and if they enter in a character, it violates that rule and it does not accept it, okay? Because a zip code is typically numeric only, okay? So let's look at what some of these views look like. Actually, I lied. We're going to look at the models first. So there are a few different types of models. There's a hierarchical model, a network, and a relational model. And for some reason, my brain and mouth don't like say the word higher. See, look, I stopped and thought about it and I couldn't say it. Hierarchical model. Okay, what it does is it shows it in a hierarchy. Okay, so that's where the word comes from. Again, I still can't say it, but that's fine. It's going to show your relationships in this, tree-like structure. Okay, each of your records is going to be called a node, and your relationship between those nodes are going to be called branches. So here you've got basically, it's like a parent-child relationship. You've got a parent as supplier A. You've got your first line of children, which are all considered siblings, as product line A, product line B, and product line C. So you can see how this has that hierarchy, where that terrible, awful word that for some reason my brain just doesn't like, is coming from. Similar to that is the network model. Now, the network model, the records are going to be organized quite differently. You can see visually this looks quite different. Each record could have multiple parent and multiple child records. That's the big difference. In the hierarchy model, typically you've got one parent with multiple children. In the network, as you can see down at the bottom, method of payment cash, it is actually going to different values there. So you kind of have this multiple relationship going on in this network model that you didn't have before. Now, last but not least, and this is really where your database shines, okay? You've got what we call a relational model. This is going to be your two-dimensional table of rows and columns, just like what we're used to seeing with a spreadsheet, okay? So your rows are going to be called records, or we can call them tuples, okay, depending upon which semantics you're using. Your columns, which are your up and down, rows are horizontal or going across ways. Your columns are going to be your up and down or your vertical. These are going to be called fields or attributes, okay? You're going to have something called a data dictionary. This is going to store your definitions, such as your type of data for your fields, your default values, and any of those validation rules for the data in your field. So for example, looking at the right, if you look at the table all the way on the right, you have a date column. If someone were to put, an alphanumeric in there, that would be a validation rule that would be broken and it wouldn't be allowed to be placed in there. And of course, as long as that data type is set to date. Again, we're going to go back to having a primary key has the exact same meaning. It's going to uniquely identify these records in your relational database. So if you look, in your relational database at the, let's say the activity name, the one on the kind of upper left, you've got each activity there, patching, overlaying, crack sealing. Each one of them has a very specific activity code, 23, 24, 25. That activity code is going to be the primary key. It is not going to be duplicated at all within that table. Then you look at the bottom, you've got a date, an activity code, and a route number. Okay, so what that's going to do is that's going to tell you that looks like it's kind of like a work order type thing, right? So on January 12th, they did overlaying on I-95. Okay, that's where that's coming from. In relation to a primary key, you can have something called a foreign key, and that's going to be a field in a table that matches the primary key column of another table. That's how you cross-reference these tables. So if you look at the tables on the left, that activity code in the bottom table is a foreign key to the top table, okay? It's not necessarily the primary key for the bottom table, but that is the primary to the top, so it's considered a foreign in the bottom. That's how you're going to get this information by linking these tables. Normalization is a way that we improve database efficiency. The whole point of using a relational database is to eliminate any redundant data. You don't ever want to duplicate data in a database. That's just causing more work, okay? So if you normalize your tables, it's going to eliminate that redundant data, and it's going to ensure that only the data that is stored in that table is going to be used from that table. And then that's basically it's in the correct location. It's all good that it's in the correct location. Typically, when we talk about normalization, it will go through stages, okay? So there is a first normalization all the way up to a fifth normalization. And typically, we like to stay around the third or fourth normalization when we're talking about doing a database creation. And again, remember, because this is an intro class, these are just terms that you need to be familiar with. If you're going to work with someone in your organization who happens to work with databases and they're talking about the normalization, we're just trying to get across to you what that means. Last but not least on relational models is operations. That's what's going to help you retrieve the data from these models. So common operations that you're going to do on these tables. You're going to select information from tables. You can join tables together. You can find where tables intersect, union, and where they differ. Okay. The thing that's going to come into play when we're talking about these operations is the SQL language, which I believe we're going to talk about in a little bit. Okay. But that's basically an overview of your relational model. Now let's look at this physical view. This is how the data is stored and retrieved from your storage media. So what it is it's basically a thumbprint of what your tables look like and how they are connected. So in this database, we've got 1, 2, 3, 4, 5, 6, 7 different tables, okay? Album, tag, tag photo, location, photo, comment, and member. These are all tables in a database. If you look closer and dig into it, so let's look at member. Member is going to have specific attributes, which are going to be your columns if you're thinking about it in that two-dimensional way. Your columns are going to have an ID, name, phone number, email, and address. It makes sense, right? Because that's all the information belonging to the member. The lines connecting these tables, you can see that they have different symbols on them. I believe these are all dashed, but the solid lines versus the dashed lines, they do mean something that is way beyond this course. We do have database courses if you're interested. But the same thing with the little circle with like the tripod underneath it, that means something as well. And the horizontal dash line that is very near the tables, that means something also. Okay, we're not getting into that again in here, but know that they do mean something. One thing I do want to point out is, so when you look at the table member, next to ID, you have that little golden key. That means that's the primary key of that table. And as you can see, each one of these tables has that golden key. That's indicating what the primary key is. Now, if you look at the table photo in the middle, there are actually 3 others under the ID where it says album ID, location ID, and member ID. Those 3 are foreign keys to other tables. So album ID goes to the album table, location ID goes to the location table, and the member ID goes to the member table. So this database is indicating those as foreign keys by using that little green arrow that's kind of pointing to the left. Another thing that you can see here is the name of your attributes and then what type of attribute it is. So for example, let's see. Okay, we'll stay with the photo table because it's got several. You've got your 3 foreign keys are an integer. Your title is going to be some kind of character with a restriction of 120 characters. Description is going to be a character, but we're going to give them up to 255 characters. Upload date is going to be of date type. I'm trying to think. I believe those are all the types that they have listed on this one. Okay, so you can see the type that it is, the name of the attribute. You can see what the keys are. You can see the relationships. This is the essence of the physical view. Most of the times, the designers of databases will live in the physical view as opposed to what we're going to see right now in like the logical view. So in the logical view, you can see this is for the same database. This is how it appears to your users and how you can retrieve it and how it can be organized. The big thing that you can see here is a difference in some of those lines have now gone from dashed to solid. Your little circle with the tripod, if you look at tag and photo, it's on both sides now instead of the line and the tripod. We still have, you know, that is still the member table. That is still the table that we just saw in the physical view. But whoever is going to be using this view of it, you know, they just want to see the photo and all they're going to see is the title, the description, the privacy, the upload date, and the view. Okay, so there's certain things that the person who has this view wants to see that maybe the other people don't want to see. Because this one, think about it, it only has 3, 4, 5, 6 tables. We had a lot more before, right? We had 3, 6, we had 7. So we're, you know, it's being curtailed to the viewer. And it's a little bit easier for your viewer to understand when they're not given so much extraneous information when it's information they don't need. So that is a big chunk of databases and just a basic glazing overview of what they are, what they look like, and some terms that you need to know. So let's next take a look at the database management system. So these DBMS, well, I guess really systems in the word, huh? These DBMS softwares have very specific components to them. You need to have a database engine. You need to have data definition, data manipulation. I don't know why I keep going between like different ways to say it. You need to have application generation, and you need to have some type of administration tool. So let's pick these apart. So application generation, this is going to be the design elements of an application using the database. It's used by the IT professionals and the database administrators. So this is where you're going to generate those reports for your users to see. Okay, it's going to be what your programmers see as the back end. So it's actually the visual component of your database. Let's look for data administration. Okay, so the administration is going to be used for tasks such as backup and recovery, security, and change management. So what you're going to be doing is you're going to determine who has permissions to perform certain functions, you know, such as create, read, update, delete, and who has access to do what. And, you know, looking back at those logical views, who has access to what logical view. Now, typically under data administration, you have somebody who is called a database administrator or a DBA for short. They are going to be the one to handle the database design and management. They're kind of, you know, the one that is able to do it all. They're going to establish the security measures that you use on your database and who is allowed to see which portions and who is allowed to do what functions. They are going to develop recovery procedures. So if something were to go wrong with the database, how are we going to recover that data? They're going to evaluate the database performance. Is there a need to redesign the database in order to improve improve performance. There we go. And in the end, they're going to add and fine tune those database functions so that it runs as smooth as possible for all of the users. Okay. So those are the two that are kind of the most well-known. Let's hop back though, and let's look at the database engine. Now, this is what's going to be responsible for the storage, the manipulation, the retrieval. This is going to be that interaction component between all of the components to convert any kind of like request from the users into what the physical equivalent will be. So if you need to see a specific report, the database engine is going to be able to generate their report, gathering the data from various tables and display it in a way that the user expects. Okay, so that's kind of the workhorse behind the actual DBMS. Data definition, this is what you're going to use to create and maintain that data dictionary and define the file structure. You're going to be able to make changes to the database's structure. It's going to basically explain to the computer what your table is going to look like, what your relationships look like, what your data is going to look like. Okay, so that has to be known. And last but not least, data manipulation. This is going to be the component of the software that you're going to use to add, delete, modify, retrieve records from a database. Typically, your data manipulation component is going to use something like the SQL language, which is a structured query language, which is where SQL comes from. It is, I believe, it is a fourth generation language from what we talked about last time. It is very simple to use, but it can also get very complex very quickly. So those are the 5 main components when you're looking at the database management system. And again, this is the part that the user sees. So the database management system would be your Microsoft Access or your Oracle or things like that. Whereas the database itself is the files that are being held on storage somewhere. Next, let's take a look at database trends. So some of the big trends out there when using a database is data-driven websites. Okay, we'll get a little bit more into that here in a second. Natural language processing. So you want to be able to use the language that is the closest to whatever your natural language is. So for us, we speak English. So you would want to have something that would kind of talk to you in a spoken English or in a written English. We're going to talk about distributed databases. We're going to talk about object-oriented databases. And there's a little bit of information about artificial intelligence. So let's start with the data-driven databases. So it's going to act as an interface to your databases. It's going to retrieve and allow users to enter data. It improves access to information. It's going to reduce the support and overhead needed to maintain your website. So when we're talking about things like this, we're talking about, like, let's use Amazon as an example. You log into Amazon, you can get all of your orders that you have done, I believe, for like the last 10 million years. I mean, you can go back quite far. So it eliminates the need for a user to call up Amazon and say, hey, I ordered something a couple months ago, I need to reorder it. What did I order? Things like that. So that's going to reduce that customer support that's needed. It's going to give users the most current information from a variety of data sources. So again, on that portion, if we're looking at Amazon, it's going to tell you there are 4 left in inventory, things like that. That's going to be considered a data-driven website. A distributed database, there is something called a distributed database management system, which is a DDBMS. Again, we love our acronyms. It's going to store the data on multiple servers throughout an organization. Okay, so you're distributing the files on different servers. Okay, there's some advantages. The design can better reflect the firm's structure. You could have specific tables held on specific servers. So say, for example, you put all of the tables that deal with cost and on a financial server, and of all the tables that deal with inventory on a manufacturing server. Okay, so you can see how those would be the most kind of the easiest and most relevant places to put them. Local data storage is going to reduce your response time. It's going to minimize your effects of computer failure. This is very similar to the redundant RAID systems that we were talking about before. There is a cost advantage. It's not limited by physical locations. Those are basically a lot of the pluses. So there's a couple different ways that you can set up these database systems. You can set it up using fragmentation, replication, or allocation. So fragmentation is going to address how you're going to split up these tables among different locations. So like my example before of putting all tables involved with cost on a financial server and anything dealing with inventory on a manufacturing server, that would be considered a fragmentation. Allocation, oh, I'm sorry, I missed replication. Replication, sorry, my brain today. So replication is different. Replication is going to say that each server is going to store a copy of the same exact data in the organization's database. Now, the thought process behind this is that when the data is closer, quote unquote, closer, and it is residing on the server that you typically use, it will run faster. Okay, so it should be faster to have a copy of a database on an East Coast server and a carbon copy on the West Coast. Okay, so people on the West Coast would access the West Coast server and East Coast would access the East Coast. If you were to cross those and the East Coast was trying to access the West Coast server, you could see how that could take longer. Now, allocation on the other hand, that's going to be a combination of the two. So if there was no need for a table on the East Coast, it would only reside on the West Coast. But there might be instances in which tables need to be replicated on both sides because that would actually be the fastest. So the allocation is just a combination of the other two. Now, yeah, that's a word. Let's take a quick look at object-oriented databases. It's okay, y'all. I actually said happy Tuesday to somebody, and then I realized it was Monday, and they didn't even correct me. It's fine. Everything's great. Object-oriented databases. So this is very, very similar to the object-oriented programming. And the data and the relationships are going to be combined within a single object. Okay, your object is going to have your attributes and your methods, which are going to be performed on that data. Okay, so again, you're looking at that encapsulation, which is grouping these objects together, keeping the attributes and what they do and what they need together into a single unit. And the inheritance. Inheritance means that you can create objects faster. Remember, we had that car situation where it's like you had a car object, but then you could create a Ford, you can create a Chevy, you could create a Jeep, etc. So that's what that inheritance is. So you do have some advantages. It supports a much more complex data management. It does handle storing and manipulating all types of multimedia, as well as just numbers and characters and dates. Okay, so really the biggest thing adding here is this can be images and video files and things of that nature. Okay, so another, like the last one is the database trying of advances in artificial intelligence and machine learning, and how that's processing and going through and creating databases that are going to know what you're wanting to see. I have a love-hate relationship with artificial intelligence, but that's okay because I think it's very misconstrued. Okay, but we won't get into that tangent today. Okay. Next, we're going to talk about data warehouses. Remember, we're still in that first section of the lecture where we're talking about what and where we keep it. So one of the things is, or one of the places that it can be kept is in a data warehouse. It is a collection of data from a variety of sources. Okay, it can just support decision-making applications. It can generate BI, that business intelligence we talked a little bit about. It is multidimensional. So let's look at characteristics. So characteristics of data in a data warehouse, they are subject oriented. They are focused on a specific area. They come from a variety of sources. Now, when I say that, it can come from multiple organizations. It can come from government, public sector, private sector, that type of thing. It comes from wherever. It is categorized based on time. It's going to be able to capture that aggregated data, okay? And typically it's used for analytical purposes. So as you can see here, you've got a data warehouse with several inputs into it, things, and then it's actually those inputs are then manipulated and stored into the data warehouse. Next, input. So remember, we're talking a variety of data sources to perform, analyze, and generate the reports. Okay, so some of these can include external data sources, such as databases, transaction files. You can have ERP systems, which are enterprise resource planning systems. They can collect data and put it into this data warehouse. You can also get them from CRM systems or the customer relationship management. So think of, the dreaded robocall telemarketer. They're getting all their information from a data warehouse. Who is supplying that data warehouse? It depends. Okay. But a lot of times when you sign up for things or you give your email and or phone number, that information can be uploaded into a data warehouse. Okay. Let's look at ETL, which is extraction, transformation, and loading. So these are processes that are used within the data warehouse. So you're going to be able to extract or collect data from your sources. You can transform that data and make sure that it fits the operational needs of whoever your output is, or process the data. And then last, you've got loading. So you can load it into whatever that end target is. Is that end target a database? Is it a data warehouse? Is it a report generated for an organization? So that loading is going to be your taking the data and putting it into the output. Now, storage. Collected information is organized in a data warehouse as 3 different ways: raw data, summary data, and metadata. Raw data means it's in its original form. Nothing has been done to it. It basically came in and it was stored. That's what raw data is, okay? Now, summary is going to be slightly manipulated and manipulated is not the right word. Slightly processed. That's better. It gives your users, totals and subtotals of different categories. It's going to be a summary of what is in there. Now, metadata, on the other hand, is going to be data about data, okay? So metadata is going to be information such as the quality, the condition, the origin. These are characteristics about the actual raw data, okay? So a lot of times you can ask for the metadata and it will say, I think one of the most common is to look at the metadata when you're looking at like a photograph or something graphical. It'll tell you where it was taken, when it was taken, the timestamp. That's the metadata. Okay, let's go back. Let's look at the output. So your data warehouse is going to use a few different things to generate reports. Okay, it can use something called an OLAP, or an online analytical processing. It can use multiple sources of information and provide a multidimensional analysis. It can generate your business intelligence, data mining analysis. It can be used to discover patterns and relationships. And I think some of those patterns and relationships are what gets you put on some of those robocall lists, right? They look at the trend of your buying and say, oh, well, they buy X, Y, and Z. They might like 1, 2, and 3. Some of the benefits. of data warehouses. So you can cross-reference segments of an organization's operation to do a comparison. You can generate reports and queries easier when you've got a variety of different sources. You can, well, my place, that's okay. You can find patterns and trends that extend beyond your organization. And then you can compare your organization to the larger global scale. You can analyze large amounts of historical data quickly. You can, it can be used to assist management in making business decisions. You can manage high demand for information from many different users with different needs and different decision-making styles. Because remember, all you're really doing is you're extending your scope of where you're getting your data from, okay? Last but not least, let's stop and pause a half a second for a question. How might a data warehouse give an organizational or competitive advantage? Okay, now let's go back. Finally, let's look at this data mart. So a data mart, I don't know, I find these names really funny and interesting, but a data mart is just like what you would think. It's a smaller version of a data warehouse. I don't know, I think data mart and I think like quickie mart. Is that the Simpsons? I think it's the Simpsons. So it's the quickie mart. Anyway, I think that's what I don't know. I have the brain of a 13-year-old boy. It's fine. It's a smaller version of a data warehouse. It's used by a single department or function, okay? So there are some advantages over the data warehouse. It is faster because you don't have as much data. So, because of its smaller size, it is going to be faster to navigate through. Improve response times for users, easier to create because of the size and simplicity. They're going to be cheaper, less expensive. They're going to be effective at targeting specific users. But there are some disadvantages. You are going to have a limited scope because you are reducing the amount of data that you are holding within it as opposed to the data warehouse. And it can be difficult to consolidate, okay, from different departments or from functional areas. Remember, your data mart is very specific. It is meant for a specific function or a specific organization, okay? So you're not going to have that broad scope of information as you would if it were a data warehouse. So that wraps up a big chunk of the data, how we store it, what's a database, how do we access it, all of that. Now we're going to move a little bit more into what can we do with that data. So first, let's discuss a term called BI. It's, business analytics, it's business information, okay? It uses data and statistical methods to get insight into the data. This is what's going to provide your decision makers with information to make those decisions and to act on them. Okay, there's different methods. There's descriptive, predictive, and prescriptive. So we'll take a look at those. The the BI is what is given as the final reports to the higher ups. So if you think about it in this way, your upper management does not want to get in the weeds of the data. They want to know the bottom line. They want to know what is your data telling you. They don't really care about the raw data. They want to know what it means. That's where we're looking at for BI. Let's look at descriptive analytics first. Your descriptive analytics is a reactive strategy, okay? So it is going to review past events, you're going to analyze the data, and you're going to provide a report. Now, this report is going to have what happened within a period of time. Now, what is this going to do? This is going to help assist on how to prepare for the future. But remember, this is reactive. You're analyzing stuff that has already taken place. You cannot change it. Okay. So we have to know what and how. And again, the biggest thing here is what has happened within a period of time. Sorry, I got a Twitter update from the the NASA launch. So we're going to be done by 8 because I want to go see this rocket outside of my backyard. I'm just saying. And anyone that cares, they actually say, clouds, clouds, go away. We're counting down to launch. We're watching the cloud cover at both Wallops and Bermuda and evaluating wind limitations for launch. They haven't really, so they really haven't said anything. And I don't think anyone here is as much of a like aeronautical nerd as me, so it's fine. It's all great. Okay, predictive. Now, predictive analytics, instead of being reactive like description, is proactive. So it is going to prepare your decision makers for future events, things that have not happened yet. So you're going to take that historical data and you're going to do predictive analysis and projections to see if you can try to estimate what's going to happen down the pipeline. Last but not least, prescriptive. And these words, like, I have to stop and think. So anyway, it's going to recommend what decision should be made. Okay, so it's going to show the likely outcome of something, of each decision. So say I can go with 3 different suppliers with a prescriptive analysis. I almost said predictive, prescriptive analytics. What it's going to say is if I go with supplier A, this will be the outcome. If I go with supplier B, this will be the outcome. If I go with supplier C, this will be the outcome. Okay, so what it's going to do, and then it's going to compare the outcomes and give a recommendation and say, I think you should go with, supplier B. Because remember what we're talking about. We're talking about talking to those VPs and those, upper level management where it's like, okay, I can choose from 3, the bottom line on X, going with supplier A is a profit, B is a neutral, and then C is a loss. We predict, that we go with A because it's a profit. That's really all they want to know, right? But you can get prescriptive analytics out of some of your big data, and that is considered your BI. Let's do a quick question. So what are the benefits and challenges of using predictive analytics?
Hey, Jennifer, this is Sam.
Hey, Sam.
Hey, we're trying to do that at Delta with maintenance
Yes.
and trying to predict when things fail.
Yes.
The problem is we forget to predict when we need to buy the replacement part.
I feel that on a spiritual level because the organization that I came from before that, you and I have talked about it. Inventory sitting on a shelf is money, right? That's not doing anything. So yes, I'm with you 100%. Trying to make that decision as to when to purchase things so that, because lead times in the airline industry are ridiculous with parts, and then getting it so that your lead time matches up with your project time, and then it can be processed internally. So yeah, it's definitely you have to be careful because sometimes those are better on paper than in like execution. At least that's what I've seen in my like professional life. Do you guys have that same problem, Sam?
Yeah, I'm not a big fan of it because, uh, historical performance a lot of time is not a predictor of future performance. I guess they tell you that about the stock market, but aircraft parts can be that way too. If they're going to fail, sometimes they'll fail early. Once they get past that infant mortality, you're good to go for a long time.
Right.
But
Right.
it's hard to predict things that don't have a consistent history.
Agreed. Agreed. Yeah, because you're going to have an outcome that's like, well, we don't know because there is no consistency. But yeah, I totally agree with that. Completely agree with that. Okay. Let's go back. Okay. 3 more to go. Not terribly bad for all in a day's work, right? So let's go into big data and what that looks like and what it means. So Conventional computing methods are unable to efficiently process and manage big data. So we're talking like obscene amounts of data, okay? When we talk about big data, we talk about the 5 V's, which is volume, variety, velocity, veracity, and value. Again, words hard, it's fine. Um, but it does have a competitive advantage because, again, remember, it is garbage in, garbage out, but the more data you have, like what Sam had just kind of related to, maybe you might be able to get some kind of consistency. Okay. And Sam, we're not talking about the airline industry because there is just no consistency in that. I'm just saying. Um, but hopefully, if you have more data, you might be able to find that sweet spot. Okay, so we're going to look at some of the tools and technologies, and then we're going to look at the risks. So the competitive advantage, it's going to provide in many areas: retail, financial services. Notice, airline is not on there. I'm just saying. Um, public relations, government, retail. If you can be ahead of what the next big thing is, you will have a competitive advantage. With financial services, like he's at stock market, if you have the idea of what the next big stock to purchase is going to be, or, are the interest rates going up and down, things like that. Advertising and public relations. I think that's where a lot of these robocalls and cold calling things come from, are some, more data. They've got more potential customers. So there is a competitive advantage out there for some industries. Tools and technology. So many technologies and applications have really contributed to the growth and popularity of this big data, right? And where data is coming from. Mobile and wireless technology, okay? Popularity of social networks, improvements in storage and affordability. If you think about it, I listen to a lot of those like true crime, because I don't know, I'm just weird, podcasts. And a lot of them will track missing people's motions by pulling records off of their phone and off of Google. Okay, so this mobile and wireless technology is really increasing the amount of data out there. Okay, so before there was never any way to track a person's location or where their movements were from A to B. Now you can. The same thing with social networks. If you've got someone who posts on social media quite a bit, you can actually follow where they're going from point A to point B. And it's increasing the amount of data because it is the number of videos that are out there, and it is the number of photographs that are out there. And because we have improved storage and affordability, when I talked about the hardware, I mean, I have a couple of terabytes sitting on my desktop right now. Um, just it's very easy to get. Back in the day, storage was very expensive and clunky and big, and it was very hard to get a handle on memory that large that you could put that much data on. Now, not so much. It's quite easy, actually. Let's follow up at the end with some privacy risks, though, associated with your big data. Okay, this is something that every organization needs to keep in mind if and when you implement a big data system. Okay, you've got things such as discrimination, you've got privacy breaches and embarrassments. I just got an email the other day, and it was, you've been compromised. Someone had accessed our database with your information, personal information on it. Um, Unethical actions based on interpretations, and a loss of anonymity. That one's a big one. Again, like I said, you listen to those true crime podcasts, and police are pulling every geolocation that somebody has accessed within a 5-day period. So you're losing your anonymity. So making sure that you kind of take these into consideration and look at them, especially as a user, and what does that mean to your users. Next, we're going to talk about database marketing. And then last, we're going to go quickly into some BI visualizations. That one's going to be really fast. So we'll be done here soon. So database marketing is going to use your organization's database of customers to promote products or services. Okay. So this is where we are getting into robocalling and emailing and spam. Okay. The main goal of this, though, is to use information that they already have in the database to implement marketing strategies. Okay. This is going to increase profits, it's going to enhance competitiveness, it's going to establish and maintain long-term customer relationships. So, say you purchased something off of Amazon, and then all of a sudden you're getting related items that are on sale. Okay. That's what we're talking about when we're looking at marketing strategies. Are they sending those coupons to all their customers? Are they sending it to a subset? Is it a coupon for a book? Um, Actually, I had that happen. I had a book on my wish list, and I got a very specific, like $5 off coupon through Amazon to buy that specific book on the Kindle e-reader. So that is marketing strategies that are coming out of the database. They looked at my wish list, they looked at what I've purchased before, and they sent me a very specific marketing tool, which is a coupon in order to buy the book. Um, let's see. Your tasks can be performed, using all of these tools. But again, the big key word here is marketing. Okay. What you want to do is you want to create a lifetime customer. Okay. So one of the tasks is calculating customer lifetime value, which is customer lifetime value is CLTV, customer lifetime LT value V. Okay. Your long term customers, your repeat customers, that's where your steady income is coming from. Okay. On the other side, and again, this is reactive. Okay, you're turning something reactive. I missed that part. Sorry about that. You're turning something reactive into something proactive. What I have purchased in the future is turning into something that is going to drive me to buy something else later on. Okay. The last thing is it does conduct RFM, which is recency, frequency, and monetary analysis. So R is recency, which is how long ago did you buy something? F is frequency, how often do you purchase something there? And monetary, how much money do I spend? So unfortunately, TJ Maxx, my RFM is probably super high. I'm just saying. That's one of my favorite stores. I don't know why, just because they got lots of weird stuff. Um, but as a consumer, I go there a lot. I go there probably as well. Actually, I was there on Saturday, so it was only a couple days ago, and I spent more money than I tell my husband at TJ Maxx. I'm just saying. Okay, so you can calculate some of these things using the information that's found in that database. Okay, last but not least, yay! And we will get out in plenty of time to go watch a rocket launch in our backyard, hopefully. If not, it might be tomorrow, or even you might be hearing me talk about it again on Wednesday. It's fine, everything's great. Two popular BI visualization platforms, and you can actually, as anybody and as any user, go on and look at either one of these. Power BI, I am a little bit more familiar with. I've used that in my corporate career, but there is something called Tableau. So let's look at the Tableau first. They are both data visualization tools. So, we all kind of know our senior management, they like pictures, they like colors, they like to see things very easily. So what you want to do is take that raw data and make it into something that I can look at for about 3 seconds and understand what's going on. Okay. These tools are used to generate your BI. And then on top of that, what it's going to do is it's going to use things like graphs and charts. Tableau has a what if analysis, but you can go to tableau.com and you can kind of see some examples of what this BI visualization software will do. Okay, we use a lot of it. We actually use some of it at Carolina University for specific reports to specific professors, or if you're on a specific committee, things of that nature. And then that way, your users only have access to information that they're allowed to see. Okay, so it's something that's going to sit on top of your DBMS, and it's going to take it one step further and create the BI out of the raw data. Now, Power BI is a Microsoft platform. You can get it at Microsoft.com and through the whole Microsoft things. It's going to allow your user to analyze and visualize, nope, that's not a word, visualize that data. You can use different sources, different formats. It does integrate with existing data and applications. You can see here a Power BI. And again, like I said, I'm more familiar with Power BI because that's what we used in my previous corporate life. But you can see here it can overlay onto maps. It can overlay onto graphics, like kind of in the middle on the bottom there. It can create charts and graphs. Anything that you want, it'll take that data and explain it to you in any way that you need it. So those are the two main ways that are very popular out there for visualization of your business intelligence. So that really wraps up everything from Module 3. I'll take that off so it doesn't look silly. So that wraps up everything out of Module 3, going from databases on through. So any questions, comments, concerns? Anybody? No?
What time's the rocket launch, and where can you see it?
It is no earlier than 8:04 p.m. and you have to look towards DC. Wait, let me see if I can pull it up.
Like, we have to look toward DC. That sounds kind of weird.
Well, they're launching it from Virginia.
Oh,
Yeah, which is why like the whole East Coast can actually see it. Which is different, which is like why it's weird for us, you know what I mean?
yeah.
But here, let me see. Where's my Zoom? There's my Zoom. Let me share my screen. Basic. Let's see if that'll share that. And then let me stop that. It may have just closed it. I'm not sure. Oh, come here. There we go. New share. Here we go. So that's where you are and where you're supposed to be able to see it in the sky. So they're launching from the coast of Virginia. And so we're in North Carolina. So we're supposed to be able to say it 30 to 60 seconds after launch. I have no idea what it's going to look like. It's probably not going to look like anything. But I'm still excited because I'm a nerd. So it is what it is.
I'll have to figure out my bearings toward
I
DC.
just kind of figured I'll go sit in the backyard and look kind of northeast.
Yeah.
But let's see. I think, yeah, if you look on their Twitter, it's the Wallops Twitter account.
Okay.
They have actually like a link. They start video at 7:40. But it actually they've been trying to launch it now since Friday, I think. Because this was last night's. It's been postponed to no earlier than Monday, May 10th at 8:04, and there's like a 40-minute window they got. So I usually turn it on at 7:40, and then the closer it gets to 8 o'clock, you'll hear them say, hold for launch, and then you're like, oh man, it's gonna be tomorrow. But they've been updating their Twitter, so I don't know, just a little fun tidbit about nothing. Okay. Well, you guys have a great evening. If you have any questions, email me. I am here for you as always. And I hope you guys have a really great evening. I'll talk to y'all soon. Bye.